In this first example, we're going to be looking at the area of the cover that goes over this hot tub. To do this problem, you have to look at what you're given. And we look at this picture and we notice that they give us a side length of 2.5, and they give us an apothem length of 1.7. And before we jump into the formula, I'm going to kind of show you the long way about going this type of problem. When we want to find the area of a shape that we don't have a formula for yet, we have to think about what shapes do we know the area of. Well, if you look at this picture, we've got a triangle drawn in here. And I can take this pentagon, I'm going to draw it here for us, and I can draw multiple radii in, and what that's going to do is create 5 equal triangles for us. So this is like that's looking down on the top of the cover. So what I did is I drew each radius in, and I've created 5 separate congruent triangles. And what I can do is find the area of one triangle and then multiply it by the 5 triangles that I have. So I'm going to go ahead and write that down. So the area of this shape is going to be the area of one triangle times the number of triangles. And if you remember from previous sections, the area of a triangle equals 1/2 base times height. Well, the good thing in this particular example is that they gave us the base and they gave us the height. So really this is going to be a quick calculation, plugging some numbers in, and then we would be finished. So I'm going to go ahead and calculate the area of the triangle right away. We're going to have 1/2 times our base, which is 2.5, and then times the height, which is 1.7. So we can go to our calculator and plug those things in, and this is going to get us, let's see here, 2.125. So the area of the triangle is 2.125, and that would be in feet squared. Okay, but that's just one triangle. So we basically just found this area here. Okay, but I want to find the total area. So what we need to do is multiply by the number of triangles. So I'm going to have here that my total is going to be that 2.125 times the number of triangles we have, which is 5. And notice that the number of triangles that were created matches the number of sides that we had. So we had a pentagon, which is 5 sides. So that's the number of triangles we're going to also have. And when I multiply that out, we're going to get times 5, 10.625, and that would be in feet squared. So there's our total area, and now we're done. Now you could do this every single time. You could take a regular polygon and find the area of one triangle and then multiply it by the number of sides. However, to kind of shortcut it a little bit, they have created a specific formula for all regular polygons. That way you're not having to work with different triangles and different measurements. And also they're not always going to give you the same information each time. So to show you where this formula comes from, we're going to use this concept that we just used in this example. So what we just said in this example was that the area of a regular pentagon or any polygon was to take the area of one triangle and multiply it by the number of triangles we had total. So what we're going to do is fill in the information we have here and then just morph it into our final formula. So we said the area of one triangle was 1/2 times base times the height, and we know the number of triangles was the number of sides, which we said was n, and then we can convert this to 1/2. Our base, we can just consider a side length. So I'm going to take times the side. And the height, we also said, was another way of saying the apothem, which is one of our new words. And then obviously n is going to stay our number of sides. Well, the unique thing here is that if we take the side times the number of sides, that's just the perimeter of the whole shape. So rather than looking at these two things separately, we can just calculate the perimeter really quickly, and that's going to be one calculation. So what we're going to do here is have that the area now is 1/2 times the apothem, we'll just call that A, and then instead of writing the side and the number of triangles, we're just going to write P for perimeter. And there's our final formula. So this stems from the concept we used in the last example. They've just converted it into one short little formula, so you're not doing multiple calculations. So the A here, that's the apothem, and then P is your perimeter of the entire shape. And this is for all regular polygons. Okay, so the key is it has to be a regular shape, but any regular polygon, it could be a square, it could be a regular octagon, hexagon, heptagon. As long as it's a regular polygon, this formula will work. All right. Let's use the formula that we just created, that A equals 1/2 apothem times perimeter, to find the area of this regular hexagon. Remember, a hexagon has 6 sides, and in this example, we're only going to be given that the side length is 3 meters. So what we're going to have to do is use that 3 meters to find all of the information we need and then plug into our formula. Now notice there is a triangle already created in this shape, but if there's not a triangle already there, I would encourage you to draw it because it's usually going to help you fill in everything you need. What we have to look at in our formula is the 2 letters that we're missing. We're missing the apothem and we're missing the perimeter. Perimeter is usually going to be the first thing I would suggest trying to find because usually that's going to be the easiest. The perimeter, remember, we just have to add up all the sides, and so if we know every side is 3, then we're going to get that the perimeter is equal to 3 times 6, which is 18. So right away we know the area is 1/2 times the apothem times 18. So the only other thing we're missing is the A, and that's going to go right here. Now, here's where it gets a little tricky. We can't just guess that length. We don't have enough information to find that length yet, so this is where the unit on trig is going to be very important. Remember, the apothem is a perpendicular segment, so we've got a right triangle here, and this is where the idea of central angles would be very, very helpful. We said earlier that a central angle is found by taking 360 divided by the number of sides. And this shape has 6 sides. So one central angle is going to be 60 degrees. That's going to be this entire angle that I've just marked on. However, the right triangle is only half of that shape. So what I can do is take that 60 degrees and divide it in half, and that's going to get us the measurements that we need to solve for our right triangle. So 60 divided by 2, that's going to get us 30. And now we have this nice right triangle that we can work with, which will allow us to do some SOHCAHTOA. And I'm going to go ahead and draw this right triangle in separately for you just so we can work with it outside of the shape. If I've got a right triangle here, we've got, this is our apothem, here's the 30 degrees. The only other side length we need to know is the bottom side because we don't know the hypotenuse. And to find that, I'm just going to divide my side by 2. So 3 divided by 2, that's 1.5. So this length here at the bottom is 1.5, because those are equal side lengths. And now I can look at my triangle. I'm going to use opposite and adjacent. That's going to be tangent. So I'd have tangent of 30 degrees equals 1.5 over A. And please remember when you solve these, if the variable is on the bottom, we're just going to switch these two things. So I'm going to have A equals 1.5 times tangent of 30. The tangent always has to go with the degree. That's an important thing to remember. And when we type this into the calculator, we get that the height is 2.6. And now that's all we needed. We knew that the A value here was 2.6. I just filled that in. And that's the only missing part of our formula that we had, so we can go ahead and fill this in. So we'll have that the area is equal to 1/2 times 2.6 times 18. And then when we do that calculation, we find that the area is roughly 23.4, and this would be meters squared. And we're done. So using a little bit of right triangle trig, we were able to find the apothem, and then we could plug into our formula. If you have any questions where any of the numbers came from, please make sure you pause and ask me in class, or write yourself a note so you remember to ask me when you see me. But hopefully it was a pretty easy example to follow.